I'm going to be going over if a magic index in an array is a of 0 to the n minus 1 is defined to be an index such that element index is equal to index. Given a array for distinct integers, write a method to find the magic index if one exists. So I wrote down this array. Within the array, what we need to do is set up a left and a right pointer. So the left is equal to 0, and the right is equal to the array length minus 1, and the middle is equal to left plus right divided by 2, and dot floor if you're using Ruby to make sure we always get the one below it. So what we're going to start off is by saying while left is less than or equal to right, what we want to do is first check to see if the array at m location is equal to m. If that, we're going to return it right away because that would be our direct pointer, our direct magic index. So in Ruby, it would be return m if array at m is equal to m. So the next thing we would want to do is to check if array m, because here what I'm considering is that if the array at m, which would be 6, if that was going to be less than this one, then the index, which would be m, which would be 4, we would want to move the right pointer to this side. So this way we would be only checking this area if that was the number we were looking for. Else we would want to move the left pointer to the right side after the m. So it would be if array at m is less than m, going back just to clarify, so assuming, because if it was less, we would assume that the magic index could potentially be to the left of it, but since it's not, we would need to check the right of it. So we're going to be updating right to equal m. So since this statement is not true, we're going to go with the else, which would be the opposite. So for that, we would do else, which is we move the left pointer and we set it equal to m plus 1, and that would give us a shortened array. So in this case, it would update it from m to 5, because we would be doing, because m, which is currently 4, plus 1 is 5, so we would have left is equal to 5, right is equal to 8, it didn't ever change, so now the new middle would be 5 plus 8 divided by 2, which is 13, which is 6.5, which is 6. So our new middle would be, so it would be 5, 6, 7, 8 for our indexes, and 7, 7, 7, 9 for what's left of our array. So in this case, we have left, middle, right. So the next thing we want to check again is we go through the loop again. So we're saying return m if array at m is equal to m. It's not. If array at m, so we're saying if 7 is less than L, then we would usually update to R, because we want to update the right side to that. But since we're not doing that, we're going with the else, which would be if left is equal to m plus 1. So the new one that we're updating it to would be, so just to show you up here, we would be updating this one to this one now. So now we're only dealing with 7 and 9 and 7 and 8. And this one would be our magic number, but we're not there yet. So now we go back here, return M if array at M is equal to M, and that's the case there. So we will return M. And the other portion was what if it doesn't exist? So I created a new trial array. So I did 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. So same thing, left, right, and the middle is 3. So here we're saying left is equal to 0, right is equal to 4 because of our previous array length minus 1. Middle is equal to 2. So if we go through the same steps, so we're checking return M if array is equal to that. It's not. So the next step would be if array at M, which is array at M, that is less than. It's not, so we would move the pointer to the 4 and the 5. So we would have left, right, and then 4 and 5, 9, and then L and M will share the same element. So in this case, my code does break because it would never find it, but I came up with this other return if to make sure it tests for that. So it would be return whatever, or in this case, null, let's say, if left is equal to R, and because in our statement this one would not work, but if we were to check the for again based off of this one, so if array at M is that less than R, excuse me, is a array at M less than M? It's not, so it would update it to left, right, and M equal to 5. So then we would, because base of the else down here, then we would go back up here, and now we would check to see return null if left is equal to R and array at M is not equal to M, which is essentially true. Okay,